All right. This is chapter 5, lesson 6, going back to some of the stuff we learned back in like October. So if you need to review any of the old chapter 5 videos to help catch up, do a combination of that and the chapter 4 stuff and maybe the late chapter 3 stuff, because we're going to graph inequalities with two variables. So quick review on inequalities. Is your less than sign and your greater than sign, which means when we graphed, we used an open circle, because like if this was x is less than 2, could not equal 2, but anything just past that would work. Your less than or equal to, your greater than or equal to were the closed circles when we were graphing, because it could equal that number. And then remember, we shaded one way or the other, because every million and billion little decimal points and fractions in between every whole number, every one of them worked, so we shaded. So here's an example. Negative 11y minus 13 is greater than 42. Got to get y by itself. It's our only variable here. Add or subtract what's not connected. So add 13 to both sides. That cancels out. Negative 11y is greater than 55. So multiply or divide the number that's connected. So divide by negative 11, divide by negative 11. Again, negative 5. We used a negative to divide. Not that this ended up negative. It's because we used a negative to divide. Our sign now has to flip. So we graph an open circle, because it cannot equal negative 5. But even negative 5.001, right here and beyond, and every little decimal in between, every one of those works. Go into graphing now. We just got done with this. Y equals mx plus b. Graphing in slope-intercept form is really the easiest way to do it, because we have our slope, our rise over run, tells us how we're moving, and our y-intercept, that's our starting point. Okay, so start there and then do our rise over run. So we need to solve this equation for y. 2x minus 3y equals 6. Add or subtract what's not connected to the variable we want. Negative 3y equals negative 2x plus 6. Don't try and combine these, and always put your x first. Don't say that it's 4x. Don't say that it's just 4. Negative 2x plus 6. So we have negative 3y equals negative 2x plus 6. Multiply or divide by the number that is connected. So negative 3, going to divide by negative 3 all the way across. Negative over negative becomes positive, and that divides out here. Ready to graph. My starting point, we just wrote, is negative 2. So down on the y-axis, negative 2. And my rise over run is 2/3, so up 2 over 3 from this starting point. So up 2 over 3 dot, up 2 over 3 dot. We got our straight line. We're combining these two ideas. We're going to graph a two-variable inequality. So step 1, you need to solve for y. Make it look as close to y equals mx plus b as you can. If there is no y, we solve for x. If there is no x, then y will just be by itself. So if we have y with no x, it's a horizontal line. X with no y, it'll be a straight up and down line. So we solve and get y by itself on one side of the inequality. Step 2, we're ready to graph. We're going to treat it exactly the same as y equals mx plus b. We use our starting point, then we do our rise over run. We're ready to put our dots. When we're ready to put a line through it, this is where it gets different. If it's a less than or greater than, also known as not equal to, it'll be a dashed line, just like we had an open circle, because it won't be able to equal that. That will be the cutoff point. But everything up to that will work. If it says or equal to, so less than or equal to, greater than or equal to, we'll have a solid line, much like we had a solid dot when we shaded. Speaking of shading, step 3. Just like back here where we shaded, because everything in there, every little bitty decimal, whether it's negative 5.01, 5 million, negative 5 million, no, anything like that. It all counts. So we have to shade. So if it's a greater than, we are going to shade above our line. And if it's less than, we're going to shade below the line. So let me show you what I mean. 3x minus y is less than 2. Step 1, solve for y. Step 2, graph. Step 3, shade. Add or subtract what's not connected. Multiply or divide by what is. Sorry, that is a negative 1y right here. So divided by negative 1, because this is a negative y. So it becomes negative 1y. Once we solve for y, y is greater than 3x minus 2. We're ready to graph. Like I said, treat this just as y equals mx plus b. So you start here at negative 2, go up 3 over 1, up 3 over 1. We're ready to put our line. It is a dashed line because this right here says it's not equal to. Okay, now we're ready to shade. This says greater than means above the line. So find your y-intercept, shade above it. And so anything above this line is shaded. What you want to do, just to double check yourself, is do a couple test points. Test a dot right here in the shaded area, which is this right here. Plug in x and y, and we solve. If this is a true statement, then the shaded area is good. Check something out here. Goes right here. If this is a true statement, then it should be shaded. In this case, 0 is not greater than 7, so it is not shaded. And then we can check one right on our line. Let's check this point right here. Plug it in. 1 is greater than 1. 1 is not greater than 1, it equals 1. So it's not a true statement, even though it's close. So that's why we have this dashed line, because that won't work. But if this was like just above or just to this side, it would work. If I changed my y up just a little bit, it would be okay. But it doesn't work, so it's a dashed line. Try and use the origin as much as you can, or use your ones, use your intercepts, try and use some zeros. It'll work out. Let's do another one. X plus 5y is less than or equal to 10. Add or subtract what's not connected, divide by what is, and we solve for y right here. Y is less than or equal to negative 1/5 x plus 2. Ready to graph. Excuse the sloppiness. It was 7th hour when I took these notes. Go up to 2, put a dot, down 1 over 5, or you go up 1, backwards 5. Either way, we're ready to make our line. Because this says equal to, it's going to be a solid line. Now we need to know where to shade. This says less than, so we're shading everything below, including the stuff that I didn't shade in 7th hour. So all this down here, all of it's shaded. Okay. Now we can do our test points. 0, 0 would be really easy to test because that multiplies to 0, becomes 2. 0 is less than 2, so that's good. This is shaded okay. Let's check above right here. We multiplied out. 4 is less than or equal to 2. That's not true, so we don't shade up there. Let's check on the line to see if my line is okay. Multiplied out. 2 is less than or equal to 2. We have it or equal to, so it can be on that line. So that's how you do those. Real quick. Remember, if you have just an x and no y, we're still solving for x. We get x is less than 2. So go over to 2. It is a straight up and down line. In this case, it's a dashed line. And everything to this side, because it's less than, is negative. So like here, where x is 1, 1 is obviously less than 2. 0 is less than 2. So you shade here. If it said x is greater than 2, then we're looking at, like 10 over here is greater. So we shade it like that. Also, if you see like an x plus 3 is less than or equal to y, to where y is by itself, but it's kind of on the wrong side, let's, just like we did back when it was, we needed this arrow to tell us which way to shade, get it over here, flip this to where it's still opening the same way, and x plus 3. So then we can graph x plus 3. It's a solid line. Greater than means shade above it. If you had Mr. Hanna's class, your homework was on 318. I think it was 12 through 21 or something like that. My class had page 318, 1 through 10.